are the Space NOAA team from San Francisco. Last year, we won grand prize in the NSS contest. My name is Kara, and this is Leo, our team leader, along with Darby and Misato. Darby, Leo, and I are in 8th grade from St. Cecilia, and Misato is from a Japanese school in San Francisco. I will now explain our proposal named Green Technologies. We subtitled this proposal the Mars Delivery System. When humanity builds colonies on Mars, there will be a need for a transportation system to ferry large amounts of supplies from Earth. We proposed a method to regularly transport up to 156,000 tons of material per year to Mars without using rocket fuel. This is the reason our proposal is named Green Road to Space. 3 space elevators will be built on Earth and 1 will be built on Mars. On Earth, a space elevator will be built in 120-degree sections based on 24-hour operation, and each zone will be divided into the Pacific, Atlantic, and Indian Ocean zones. Since people and goods will be transported to Grand Port by plane and ship, we selected locations where airports and ports, with a depth of 20 meters or more, can be constructed. This is Jarvis Island in the Pacific Zone, an uninhabited island that is a territory of the United States. This is Ilha Caviana, located in Brazil in the Atlantic Zone. This island is fixed at the mouth of the Amazon. This is Fuvahmulah in the Indian Ocean Zone and is located in the Maldives. It is adjacent to the Strait of Malacca, which is one of the major shipping routes.
I will now explain the zoning for the space elevator, which consists of 4 parts, which are the Grand Port Zone, Visitor Center Zone, Control Center Zone, and Mars Gate Zone. This is the Ground Port Zone. It is the base of the space elevator and has an airport, a seaport, a cargo stockyard, etc., so people and cargo can come to the elevators easily. These facilities will be constructed underground as much as possible to conserve nature. This is the Visitor Center Zone. There's an amusement commercial facility with the theme of zero gravity. It is called the Space Park with a capacity of 30,000 people. The space elevator has a maximum capacity of 2,000 people and takes 4 hours to get to the Visitor Center Zone. The space elevator operates twice daily. This is the Control Center Zone. All facilities other than the Grand Port Zone and Visitor Center Zone are managed here. This zone has a space solar power plant with a radius of 50 kilometers. This is the Mars Gate Zone. This facility is not open to the general public. It is mainly used as a takeoff and landing facility for colonies on the Moon and Mars and planetary travel. This is the Space NOAA Elevator Safety Management Observation Station, built every 100 kilometers. Each observation station has tethered ultrasound sensors that are analyzed by computer in the control center to ensure its safety. If an accident occurs, a maintenance vehicle will be on site within 20 minutes and fix it.
This is the space container loading plan. The Mars delivery system can send up to 156,000 tons of materials to Mars per year with a single space elevator. This equates to 9,286 launches, as each Falcon Heavy payload to Mars is 16.8 tons. The design of the space container takes into consideration of the transportation system on the ground, and the maximum size of the space container is 3 meters times 3 meters times 15 meters, and the maximum loading weight, including the container weight, is 6.5 tons. 25 space containers will be bundled at the Grand Port cargo yard and sent to the Mars Gate using the space elevator. Since artificial gravity is working on the opposite side of Earth, cargo is loaded into the space container ship by hanging it from a rope. The space container ship can carry 200 space containers at once. 4 of these space container ships will be bundled together, and 4 movable ion engines will be docked in the front and back. The space container ship is unmanned and autonomous, and once the magnetic mooring of the space container ship with the engine attached is released, it will begin flying in a uniform straight line. The speed is 11.2 kilometers per second. Space containers will be lowered to the surface using a space elevator built on Mars in the reverse order of loading on Earth. The space container ship leaves the landing pad and returns to Earth. After lowering the space containers on the ground, the empty racks are assembled and reused as frames for large agricultural facilities. Space containers will also be connected together and used for walkways and warehouses at the Mars base.
This Mars delivery system is a transportation system that uses the centrifugal force and gravity of a space elevator to theoretically travel between Earth and Mars without fuel. Calculating the Mars gate's velocity as Earth's escape velocity, the length of the tether is 147,900 kilometers. Turning off the magnetic docking system of the spacecraft to turn the landing pad will allow the spacecraft to automatically rise due to artificial gravity and be launched towards Mars at a speed of 11.2 kilometers a second. If we build a space kilometer on Mars like we do on Earth and set the speed of the landing port to 11.2 kilometers a second, we will be able to use Mars's gravity to return to Earth without using any fuel. When this process is repeated, it will be possible to travel between Earth and Mars permanently without needing any fuel. This is the space solar power generation using perovskite. The radius is 50 kilometers and the solar panel's area is 5,888 kilometers per squared. The perovskite solar panel has a power conversion efficiency of 21.6%. This generates approximately 14,000 terawatts-hour annually, assuming a transition of loss of 7%. This image shows the Fukushima Daiichi nuclear power plant, which exploded due to the East Japan earthquake that occurred on March 14, 2011. It was the worst nuclear power plant accident in human history, with 3 of the 4 reactors exploding. Humanity once again learned about the dangers of nuclear power. It is estimated that between 7 and 8 million people die from air pollution every year. Fossil fuels and vehicle exhaust gas account for a large proportion of air pollution. Based on the power consumption of Japan's Shinkansen trains, we estimate that the annual power consumption of the Space NOAA elevator is approximately 9,000 terawatts-hour. The annual total of fossil fuel and nuclear power generation in 2022 is approximately 12,000 terawatts-hour. By paying 4,000 terawatts-hour each from the 3 Space NOAA elevators, it is possible to completely abolish fossil fuel power generation and nuclear power generation. Alternatively, if the entire area of the 50-kilometer radius is designated as the solar panel area and the power conversion efficiency of perovskite is increased to 30%, a similar effect can be achieved with 1 space elevator. This is why the Space NOAA elevator is the true definition of the green road to Earth. The Space NOAA elevator's biggest proposal is the length of the tether of 147,900 kilometers. This length gave the apex anchor the incredible power of Earth's escape velocity. As a result, humanity will take a new step towards space exploration. The Mars Delivery Service System uses this to develop a powerful zero-emission system that can theoretically fly back and forth permanently between Earth and Mars without using any fuel. This groundbreaking elevator system is grander than any project ever done by humanity, and it promises new dreams and hopes for humanity.